This is Joystick and this is servo. And today we are going to control the position of a servo with the help of this joystick. But first, what is joystick? It is a kind of potentiometer, or we can say two potentiometer arranged in a perpendicular axis so that it can control the rotational position in both direction along x-axis and along y-axis. And controller also comes with a switch that can be used for the other purposes like this way. But to keep the video simple, today we are going to use just one axis to control our this servo, as we are only having one single servo. This joystick outputs analog signal. We will create a circuit and a program that can read the analog signal and display it on the serial monitor. But first, let's see the pinouts of this joystick sensor. So here, as you can see, there are 5 pins, and namely ground, second one is 5 volt, third one is voltage along x direction and voltage along y direction, and the last one is for the switch button. So let's build the circuit. To build the circuit we need two things. One, our joystick sensor, and another one is Arduino Uno or Arduino Mega, anything we can use. So first we will give the ground and voltage pin from our Arduino itself. So here our yellow color wire is the ground wire from the sensor. So we'll attach that to the ground pin in the Arduino. And then next we can see this purple wire is the 5 volt. So we will attach this 5 volt to our Arduino's 5 volt pin, which is just beside this one. Now as you can see, our voltage along X is the orange wire. So we will pin our orange wire to the A7 pin of the Arduino, which will read our analog output from this sensor. So this is our circuit. So let's begin with the code to read the analog signal from our joystick sensor. First we will initialize a pin, which will be our pin A7. Now let's initialize one more variable to get the readings. Now here we will establish a serial communication with a baud rate of 9600. Here first we will read our analog input using analog read function, which we will read from pin A7. And we will print that on our serial monitor. Let's compile and upload this to our Arduino Mega. Now as you can see, our the value output by the sensor is varying as we are moving the sensor along the x direction. Okay, so extreme right is making it a 0, and extreme left is giving a value of 1023, as it is a 10-bit output from the analog, and in the middle it is giving 513. So we will map this output to our servo position so that we will get a servo position from 0 to 180 degree. So let's build our circuit with the servo in it. Now let's modify the circuit and attach the servo in it. We need our servo, and we need a breadboard and a quick power supply, which we will be getting from this battery. Okay, so we'll keep this our joystick circuit as it is, and we will attach our servo. We'll use a pinout diagram to know what pins are used for what purpose in the servo. So here the brown is for the ground. Okay, so ground is becoming blue, so we'll add that blue into the ground port here in our board, and the middle one is for the power, which is our white wire. So here we are adding this here for the power. Now our yellow is the PWM pin, which we will add at our pin 30. Now here we will need one more thing to make a common ground between our sensor and our servo, between Arduino and our servo. So we'll add this one more pin here. And here in the ground section. Now let's modify this code. We can control our servo. So first I will include here the servo library. Let's initialize our servo variable here. Servo1. After that we will also initialize our PWM pin, which will be our pin 13. This is our readx variable to read the analog input. After that we will have one more variable for the position. So as we have begun this serial communication here, we will also attach our servo to our PWM pin with the help of servo .attach function. After that, first as we are reading the analog input from our pin A7 to the readx variable, now we will use our position variable and will map the pin A7 value, the readx value, which is from 0 to 1023, as it is a 10-bit value, to our 0 to 180 degree position in our servo. After the reading of this, we can write this to our servo as well. So this servo.write function will tell the servo to go to the particular angle. Okay. Also here we are going to display our position in the serial monitor. We can add a delay here so that our servo can reach the position, but still without the delay it will work perfectly. So let's compile this video and upload this to our Arduino Mega. Done compiling, done uploading. Now as you can see here, we will move our joystick, and similarly our servo will be controlled.